This is part 2 of Daemo.NET tutorial. We look at logs now. You can see the user who's asking the question and the role of the user. You see that analysis mode is disabled. Let's now switch on the analysis mode to true and then see how Daemo responds the same prompt under analysis mode. We pass on the username in the context and then prompt list all employees. Enabling analysis mode, Daemo separates data retrieval from analysis. First, it fetches the data deterministically, then performs analysis only on the retrieved dataset. There is no hallucination and only actual table data is used. In analysis mode enabled, the response includes the analysis of the data, the raw JSON of all employees, and a count of the retrieved employees. You can see it has retrieved all the employees in the JSON format along with the analysis and the count of 60. Let us see how to prompt the Daemo AI agent from our application via a chat controller API. Next, let's make a chat endpoint to connect to Daemo. We create a chat controller. We pick API controller. Once we create the controller, we inject HTTP context accessor to retrieve logged in user info, and we also inject Daemo client for API interaction. We add a constructor here and then pass the HTTP context accessor and Daemo client to the constructor to be used for the dependency injection. Now we create a chat request object with fields for message and thread ID. This is the object that we send to Daemo. We create a method for chat response. We have parameter from body chat request. When we access this endpoint, we pass on the chat request as a parameter, and then we are having the variables of user and role. We get the user from the HTTP context accessor, the information of the logged in user, and then we also have a context parameter. We're using a keyword username and then populating it with the username of the logged in user. And now we have the agent client, which has method process query async. And then we are passing the information from the chat request into the parameters of this method, the message and the thread ID and the role from the variable and the context dictionary that we made. For now we put analysis mode as false and then we return the result. We also decorate it with a HTTP post. Now we run the application in Postman, and then authenticate login in Postman with the anti-forgery token, and then in the body we have the content as application JSON, and we give the raw JSON message and thread ID. For the first request, the thread ID would be an empty string. We do a post request of our chat endpoint. Click send. And then we go to the body of the response, and we see that Daemo has responded with the data from the database table employees. You can look at the raw response. You can see that this data is exactly matching with the data in the employee table in our database. Next, we create a chat front-end page. Because this is Blazor server hosted, we can inject the demo client directly and integrate authentication. The front-end HTML markup provides a chat interface for users. We add this razor component. I already copied all the code for this chatbot to save time. Remember, we passed an empty string for thread ID for the first prompt while testing in Postman. This is where we declare a variable for the thread ID in the front-end page. We then pass the prompt and thread ID to the process query method of the Daemo agent. The JSON response for the first prompt returns a thread ID provided by Daemo. This thread ID can be stored in variable back in our application and passed as a parameter for the subsequent prompts. This is how Daemo agent maintains the context of the conversation. In a Blazor WASM page, you could use a HTTP client to call your backend API endpoint for the chat controller, sending the prompt, thread ID, and the authentication headers, either the JWT or a cookie authentication in the headers. This is an example of calling your backend chat endpoint or HTTP from a Blazor WebAssembly frontend page. Back to our server hosted frontend page. We can run the application. Now we are going to log in with the user with admin privileges. In the nav menu, we include this chat page in the authorized view so that chat is available to authenticated users. Now we prompt list all employees, and you can see the response from Daemo. The LLM has processed the data and then has given a natural language response. You can use some markdown libraries to format this into a proper table. We can switch to another user without the privileges and then see that it gets an empty data set because the user was not admin. So we enforce role-based access control. We go to the logs. You see that the first request was from tester 5 who has admin privileges. You can see the raw template of the LLM. It has processed the data and then the JSON response and then the JavaScript function call. If you go to the other log for the user without admin privileges, you can see that the LLM has tried 20 times to get the data but was still unable to process the request because the function is only allowed to run with admin privilege. Now we'll see analysis mode to true. Run the application again. Then log in. In chat, list all employees. And then we can see now, along with the list of employees, Daemo has done some analysis of the data and is displayed in the chat bot. Analysis mode provides insightful summaries without generating any hallucinated data. Let us do another prompt that requires passing the user ID as a parameter for the query. Again, we use Daemo Genie to generate our function. We provide the model of the table, employee, to the Daemo Genie prompt. We are prompting Daemo Genie to create a function that retrieves the joining date of an employee. We pass the application user ID as the parameter to the function. Let us wait for Daemo Genie response. We see that Daemo Genie generated multiple responses. If we review the output, it provides 2 code snippets for retrieving the joining date. We select the second snippet because it returns a single joining date for the specific user. We copy this and go back to our application. We navigate to the functions folder and copy and paste the code there. We update the application DB context, and then we add the Daemo function decorator. Then we describe what the function does. Again, we assign the roles of admin and user. You can also add manager. Essentially, all roles are allowed to access this function. We then add a parameter description to retrieve the application user ID from the context parameter of the agent query. We retrieve the application user ID from the user variable, which we already obtained from the authentication state provider. We pass this application user ID as key value pair into the context dictionary. The application user ID is supplied from the user variable and passed into the Daemo client request. At this point, the user context is fully wired into the query pipeline. Once we have done that, we can run the application. Actually, before that, we go back to the code and then change the analysis mode to false because we just want the joining date. Now we go back and run the application and log in, and then see that the chatbot replied with January 1st. We go to the database and verify that it is correct. So there's more documentation available at docs.daemo.ai. You can find quick start guides for Node.js and .NET. There are also reusable code snippets that you can integrate directly into your application logic. There are examples available for both C# and Node.js. I hope you got the general idea of how to integrate Daemo SDK into your existing .NET application to make it AI ready without requiring any changes to your workflow or deployment methods, while fully compliant with the role-based access control requirements through this video. Let me know in the comments if you would like a tutorial video for integrating Daemo with your particular use case, be it a different authentication system or a different data source. Have a great day. Thank you.